from the registration list, I can see the attendees are from different countries. Thanks for joining the webinar. Thanks also for your participation. Okay. So I'm Natra. I'm the MEITA project leader, and I will be moderating the whole today's webinar session. And on behalf of all MEITA collaborators, welcome to our first webinar series on Sustainable Aquatic Resource Management in Mangrove Ecosystem via Internet of Things application. But before we begin, just a few notes on the housekeeping. First, please ensure that all microphone and videos are turned off all times. And second, should you have any questions, please use the chat box for Q&A at the bottom of your screen. I hope you can see it, and set it to everyone, right? We will first basically start our session with talk, followed by panel discussion at the end of the session, right? Now, before we move on to the speakers, let me first start by giving an overview on this project. Right? I hope the host can somehow make it, in presentation mode. Can you set it to presentation mode? Wait, I'm still waiting for them to share my slide. What else I have to share myself? Okay. Wait, is there a problem in sharing my slide?
We couldn't see your slides.
Yeah.
I think that the share button is not enabled.
It's the same for me. I can tell you already. The sharing button is disabled, so I cannot share.
Normally we will pass when you are a presenter, they will pass the presentation icon to you. Okay, so I'll share my slide myself. Oh, I hope you can see the slides now.
Yes, we can.
All right, okay, good. Okay, so back again. All right, so let me first give an overview.
Hi, Doctor. There is a technical problem here, so we need you to share your own presentation because it's stuck here.
But the slide is already on. Or should I share my slides? All right, okay. Sorry for the technical problem. Okay, so I'm sharing my screen now. Okay. All right. Okay, so MEITA is actually an EU-funded grant, basically to ensure the digital connectivity between the Asia Pacific and also the European research and education communities. So it involves two networks. One is known as TN, okay, which is the world's largest research and education network with 50 million users that interconnects universities and research centers in all the participating countries in the Asia Pacific. And the second one is GN, which connects around 40 million European researchers and academic in the academic world. So basically, Asia Connect link these two networks where all the participating universities can share all sorts of data and activities using this network. So that is why under this project, okay, there are several countries that involved and several universities. We have altogether 11 different universities from 8 different countries, which are from Malaysia. We have also researchers from Belgium, Bangladesh, Philippines, China, Thailand, Australia, and also New Zealand. And our big vision is actually to inspire innovation through the use of technology and also active collaborative engagement towards the sustainability of mangrove, with the mission to connect and also empower the global community on the knowledge of mangrove ecosystem and its resource management through the use of technology. So under this grant, we have 4 main objectives, which is the first one is to connect all these multidisciplinary researchers through data and resource sharing on mangrove studies, where we would apply the use of technology, which include IoT sensors and robotics in mangrove environment in terms of monitoring the mangrove environment and also the biodiversity, and at the same time transfer knowledge to the community in the form of webinars, bina, and also outreach program. And at the end, all the data, all the activities that we have conducted, we will be sharing it through an online course and also in our website. We have a specific mangrove site for this purpose, which is in Selangor, where it is situated in the west coast of Peninsula Malaysia. The site is known as Sijangkang Village Mangrove Recreational Park, and they even have their own Facebook page. So basically, the community here, they're very active. They have basically transformed the mangrove site, okay, from an illegal dump site to a beautiful recreational place. So I would like to invite all of you to visit this place one day. So these are among the activities or program that we are currently, planning to have, and also some are already ongoing, where we are now currently, in the process of installing IoT application. So we have the IoT system now in the village itself, right? And where we would focus on the 6 main case study, which is the mangrove, the aquatic biodiversity, water quality, robotics, IoT, and also the socio-economic. So we will be hearing some talks about some of the case studies today. And most of the activities would consist in terms of community outreach program in the form of educational activities, where we would train local stakeholders and also the community in terms of good mangrove practices and in terms of its management. At the same time, we are also planning to educate the young generation on the importance of mangrove ecosystem and its sustainability, and also manage aquatic resource to ensure the sustainable living of local coastal community. And we have already an official website for this purpose, www.meita.org.my. You can also access the website. We have given the link in the chat box. And this website will be somehow be the link between all the academics, all the researchers around the world in terms of sharing knowledges in mangrove ecosystem and also the use of technology to manage mangrove in general. I think that's all from me. So, okay. And then without further delay, I would now, would like to invite, the speaker of next session, right? So today, basically, we are very fortunate to have 4 excellent speakers from different disciplines, ranging from mangrove, IoT, robotics, and the socioeconomic parts to basically share their latest insight from local to global perspective, right? And without further delay, let me introduce you to our first speaker, right? He's a mangrove expert and he doesn't really need an introduction. I think all the mangrove communities, people know him, right? So, welcome, Prof. Farid. So let me give some introduction about Prof. Farid. Prof. Farid, I always have problem in terms of pronouncing his name. Farid
Dahdouh-guebas.
Dahdouh-guebas. Okay. So Prof. Farid Dahdouh-guebas is a full professor at the University. Okay, this is another term that is very hard for me to pronounce. Libre.
Yes.
Brussels.
Bruxelles.
Brussels, okay, where he leads the Laboratory of System Ecology and Resource Management, and he also chairs the Department of Organism Biology. He works on mangrove forests since the 1990s and contributed to mangrove research in over 20 countries in the Asia, Africa, and also in the Americas, with long-standing projects in the Kenya, Sri Lanka, and also Malaysia. He published about 190 papers in peer-reviewed journal and received various international awards. Prof. Farid is also the founding director and general coordinator on the Excellent Label EC-funded Erasmus Mundus Joint Master Degree in Tropical Biodiversity and Ecosystem, also known as Tropimundo. Okay, Prof. Farid, now the screen is yours.
Thank you very much for this introduction. Assalamu alaikum to everyone and Ramadan Kareem, first of all. Well, without much further ado, I will just share my screen and go to the presentation for today. Can you tell me if you can see my screen in presentation mode?
Yes, clearly.
All right, thank you very much. So, because it's a very interdisciplinary audience with people from robotics, from all kinds of sciences, which may be less familiar with the mangrove tree and the mangrove flora and fauna in itself, I thought of giving a global overview of mangrove ecosystems and especially show this transdisciplinarity also within mangrove ecosystems. If we look at mangroves, this is the typical view that we are getting with a forest that is flooded. But what is a mangrove? Well, a couple of years ago, we came up with several worldwide experts. Sorry, it's a problem. Yeah, with a consensus definition of about what mangroves are, because usually when in older literature, when we talk about mangroves, we refer to the trees, but it's much more than just the trees between land and sea, with some tree and non-woody vegetation. It's also the fauna, and that in this consensus definition is very important, that the mangroves is not only the trees. And to give you also a bit of history, well, mangroves are of course found in many different countries and they have many different names. I've even been told that mangi is some kind of Malay or Malay dialect for Avicennia. It has not been confirmed so far. But in different languages, Portuguese, mangue, Wolof, it has its origin, or that's one of the stories, of course, that mangue comes from the Wolof word tree, and then the grove is from English, of course. In French, we talk about manglier. So you see throughout history and throughout the world, mangroves are very important and have several local names. But very early on, I want to indicate again that it's not only now trees and animals, but also people. So in the mangrove, I consider the mangrove a social ecological system. And I'm not going to go into details of this figure. You can read about it in our paper, but it basically tells you that there is a lot of interaction and a lot of variables, rather fast or slow, that interact within the mangrove social ecological system. So there is almost no forest without the people, and there is no people without the forest, or at least it would be difficult to survive for many fisher folk around the world if the mangroves were not there. In the Philippines, the word nila, Samay nila, means the place where the nilas are growing, which is also a mangrove species, Ciphifora hydrophyllacea. And that's where Manila comes from, the capital city. You may also know that even the ancient Greeks already Theophrastus made certain reference in their texts that point to mangroves in that area. So we're talking about Iran area now, actually, in this text, Persia. But the word mangrove was not known then. So they were describing, for example, where the tide is felt, the trees are all eaten up to the middle of this by the sea and are held up by their roots so that they look like cuttlefish. Well, it can only be a mangrove. They even refer to coastal protection. They even refer to salt tolerance. If we stay in Persia, Avicenna comes from the name Abu Ali Sina, which is the father of modern medicine and many other scientific domains. So this is a small historic introduction of how far mangroves and reference to mangroves go back. I will also tell you in a moment that there is a problem with these historic references, but that's for a bit later. I also want to show you the very first mangrove tree that has been painted unequivocally, and that is from 1637, when a Dutch painter, Frans Post, went to Brazil, to Itamaracá Island, and painted this particular view. And if you zoom in to this part of the photograph, you see for the very first time in history, a figure that shows unequivocally the aerial pneumatophores and the aerial roots of Avicenna. But mangroves, before you can find them in all these places, they need a certain number of conditions to grow. And I also want to emphasize these ones because that's very important when you establish a plantation or a follow-up of any kind anywhere. So your coastline usually is protected by bays, lagoons, islands, coral reefs, and has a gentle slope. Mangroves can be found in lagoonal systems, in tide-dominated or wave-dominated systems, or a mix of these. Recently, it has also been subdivided more according to the type of soils that you get. Is more terrigenous or carbonate soils? Is it the type estuarine, lagoonal, open coast? So there have been several recent classifications of the coast where we find the mangroves. They're also dependent on currents for their dispersal, because they are very often notohydrochoric, which means that they float and they follow the currents of the earth, and it's for the ocean currents. And you can look into the perpetual ocean model that you find on YouTube, where you can see all these different types of currents along the different coasts. Also, mangroves, they often grow in a mix of fresh and salt water, which is brackish, but they are facultative halophytes. They don't really need this. They're pushed away to salty habitats because they are outcompeted by terrestrial plants, but they're facultative halophytes. They do grow better when there is a little bit of salt. That's the most recent findings, but they don't really need it. Of course, when we talk coast and intertidal areas, we have a tidal amplitude, which will very often determine how far and how big your mangrove forests are. And your substrate, of course, has to be very soft. Sometimes you find them in coral rubble, but that's only because below the coral rubble, there is a soft substrate like sand, clay, or silt. And then again, in the type of forest that you find, you have overwash forest, fringe forest, riverine forest, so basin forests. And all of these differ very much with respect to one another in their conditions of salinity, tidal amplitude, and so forth. And the last statement I want to stop by is that mangroves have viviparous propagules, which is true, that they are torpedo-shaped to plant themselves into the soil under the parental tree. That's very often the case, not always. So sometimes they fall in the water and they float away. And that's also why we always have to make sure that mangroves, when we plant them, they are planted in the correct intertidal area. And when within such a mangrove, the water is going to rise lower, you see that the possibility to float away for these propagules, well, in the roots is difficult because you have the roots. But once the water reaches the stem area, there is no steric hindrance. So that's when most of the propagules really float out of the system. Now, these roots, they are also very important. They are roots, so they are absorbing, but they're also aerating the tree because the soil is so poor in oxygen. And another adaptation which is very important to consider is that they have to deal with salt, because mangrove trees are not trees that got stuck in the water before colonizing the land. No, they colonize the land first, and then after, so it's evolutionary, plants colonize the land first, and then some trees, the aquatic trees, they're returned back to aquatic environments, which means that their standard condition is fresh water, is the land condition. So when going to the salt water, it's very, very, very harsh for trees. So they need salt balancing, salt exclusion, salt excretion, and all these adaptations to be able to grow in the But mangrove forests are not only trees, also fauna, mix of terrestrial and aquatic fauna that is going to migrate from seagrass beds and coral reefs, but also the resident fauna, the intertidal fauna with a lot of crabs. Following slides are very touristic, let's say. It's a touristic tour through different countries where you can find, of course, mammals. We talk about Bangladesh, the Sundarbans is very famous, bats, mangrove rats, and so forth. You have all by all quite few amphibians because it's salty, of course, but reptiles, all these cuties here. Of course, birds, many birds. I'm not a bird specialist, but mangrove sites are very often associated to upwelling, or at least related in some areas, like in Mauritania, for example, to upwelling, which makes the whole area a bird sanctuary for wading birds. Arthropods of all kinds and sizes, very important. I think there is still a lot of research to be done about arthropods and about their functions within. And of course, all kinds of fishes, because the mangrove, they form this nursing, spawning, hatching habitat, especially because of the root system. And as I said before, crabs, a lot of different crabs. I think it may be one of the most important epifauna, macrobenthos, in terms of numbers, at least. Not to forget that some are extremely important in commerce, in selling to So in looking at these great photographs, they're not mine, by the way, they're very nice environment, very unique, very beautiful. And we have this hashtag, mangroves are awesome, mangroves are beautiful, on Twitter, so please use them. Now, why are they so beautiful for all these animals? Because of this function, breeding, spawning, hatching, nursing ground, but also as a refuge for fish, other marine and terrestrial species, also for food, also for people, by the way, also for anti-erosion. So the mangroves, they provide an anti-erosion function against ocean influences. And of course, it's a forest, so it has a lot of primary production. And recently, it has been found also that the carbon storage in a mangrove is the threefold of what you find in any other ecosystem, including the tropical rainforest, taiga forest, whichever forest. Mangroves is 3 times higher. Now let's have a look. Now it's a long list, actually, because I want this really to communicate this. What are the functions? You have this primary productivity, you have herbivory in mangroves, you have dry organic matter breakdown, remobilization of nutrients, import and export of carbon. There's all these trophic processes and functions. You have functions regarding non-trophic nutritional resources like nitrogen fixation, nitrogen mobilization, phosphorus mobilization, and so forth. Not only those elements, of course. Regarding other resources, you have this niche creation for animals. You have oxygenation, also by the crabs in the soil. You have light attenuation, freshwater collection for certain animals. You have pollination, bioturbation. These crabs, they're very often considered ecosystem engineers because they change the topography of the soil. Salinity, pH buffering. So that's a lot of function. And it's not only about these ecological things, it's also about the ethnobiological or the socio-ecological. And let this be a very big part of the research that I do in mangroves. Let's say 1/3 is ecological, 1/3 is ethnobiological and socio-economical, and the fourth and the third part is actually management and governance. I want to, the last few slides, show you a few things from different countries. Your neighboring country, Indonesia, where the Ahmad people actually, they believe that creation of man happened through the mangrove. In their spirituality, their creator carved little puppets from mangrove wood and played the mangrove drum, and that's how humanity was created in their spirituality. So to show you how in some countries the link between mangroves and people are very, very, very strong. I give a few examples from my own research in different countries. You can see that fuel wood, construction wood, medicinal purposes are coming back in almost every country that you have mangroves. So people really live in mangroves. In some areas, they even organize the nicest dressed mangrove lady in Brazil. And if you can look at what she's wearing, it's all composed of crab legs. The link between people and crabs in Brazil is very in mangrove, at least, is very strong. I will show you another slide of it. Leisure tourism, mangrove tourism is not $1 billion, but $1 billion industry. If you look at this recent paper from Spalding and Farid, there are thousands and tens of thousands of TripAdvisor reviews regarding mangroves, all corners of the world. And of course, in many cases, the people, they themselves, apart from tourism, they also depend on mangroves in their just daily survival, cutting wood, cooking. Like this is the slide that I promised you about the crabs in Brazil. There is a very close association with fisheries, of course, and fisher folk. Well, in all kinds of countries, this is from Sri Lanka, but I can show you a fisheries example in almost every country. And if you look at the value, these are old figures, but I think they're still very valuable. It's again in million and billion dollars per hectare of worth. If you look at mangroves or tidal marshes, and if they decline, you have big economic losses that are associated. So if we look from the human side, wood products, construction wood, fuel wood, other wood products, chemical substances, food and drinks, extraction of raw materials like sand, I'm not saying that it is always without impact, because I will also show you in the last two slides that it is, of course, sometimes destructive. Photo from Malaysia, the fireflies in Matang. Fishing, hunting, animal rearing, enjoyment, looking at the fireflies, social, cultural services, they're all very important. But to end, sometimes the disservices of mangroves are emphasized. And that's a pity. And it happens historically also. So coming back to where I started from and in history, if you look in history, sometimes the mangrove is shown as a very dangerous forest. And you see here the palétuvier. Now it's palétuvier, but it's French for mangrove tree. And immediately you see the crocodile, very dangerous. And there is another animal there. It looks very dangerous. Even the very kind dugong was historically shown as a fierce animal with long teeth. And again, even in the Americas, one of the first drawings of mangrove or herbarium sheeted mangroves, Gatsby 1743. Again, the crocodile is there. And even some international organizations these days, like WWF, IUCN, they talk about the mangroves quite negatively to then switch and say something positively. But we should stop doing that, because mangroves are much more beautiful than they are ugly, and it actually leads very much to destruction. If we look at how much mangroves have been destroyed, the losses are enormous. In this recent paper from 2020, it has been confirmed again. Losses are enormous because of aquaculture, because of commodities, because of extreme weather events also. And if you talk about aquaculture, well, aquaculture and oil palm is a very big problem now in Southeast Asia. You can see from this paper from Richardson and Fries what is the cause of deforestation in since 2012 in so this is the last two slides, I think, with photographs of how beautiful mangroves are. And these public perceptions, they really matter for conservation. So if you portray the mangrove as something nice, then people will be interested in it and will see how much it contributes to human well-being, to all these ecosystem services that we know. And if we talk about mosquitoes and malaria and so forth, then economic developers are going to say, okay, then we just cut the mangroves and let's make a big touristic resort. And what happens with those resorts and the mangroves are gone, that we saw, unfortunately, in these natural experiments that the tsunami in 2004 taught us. So with this, I hope I haven't taken too much time. With this, I conclude my general introduction about mangroves. Thank you for listening.
Thank you, Prof. Farid, for a nice overview on mangrove ecosystem, which are very important to all sorts of organisms, ecologically and also ethnobiologically. And I'm quite surprised actually when I hear some people associate mangrove with, dangerous ecosystem. You have heard that before? With crocodiles.
Maybe not in Malaysia, but definitely in some other parts of the world.
All right. Okay. Okay. Then let's go hand in hand, trying to educate this, or at least provide awareness to people that mangrove is really a beautiful organism and affect a lot of things in the nature. Okay. Now let's move to our second speaker from mangrove. We have an expert on IoT and also network. Please welcome Professor IR Dr. Aduwati Sali from the Engineering Faculty, Universiti Putra, Malaysia. So let me read a little bit on her biodata. Prof. Aduwati Sali have been involved with EU IST Satellite Network of Excellence 1 and 2 from 2004 until 2009. She is also the principal investigator and collaborator for projects under local and international funding bodies, namely Malaysian Ministry of Science, Technology and Innovation, or also known mostly, Malaysian Ministry of Higher Education, Mohd, Malaysian Communication and Multimedia Commission, MCMC, Research University Grant Scheme, RUGS, and also known as Putra Initiative Grant, and also the Academy of Sciences for Developing World TWAS Comstack Joint Grant. Not to forget some international grant which involve EU Horizon 2020 Research Innovation Staff Exchange, EU Erasmus Plus Capacity Building for Higher Education, and ICT Japan ASEAN EVO. So let's hear from Prof. Adu on IoT and also network.
Thanks a lot, Dr. Natra. You can hear me?
Yes, clearly.
Okay, and you can view the slides, I
Yeah.
hope.
Yes.
Okay, thanks a lot, Dr. Natra, for the introduction. I'm Aduwati Sali. So regarding this project, MEITA, thanks a lot for introducing us, for the opportunity given to us to join. So today I would like to present another project that is quite relevant to MEITA, which is almost concluded. Inshallah in June, 30th of June. So it's towards the end of the project, entitled NAPC, Network ASEAN Peat Swamp Forest Communities. So this project is funded by NICT Japan, in which the members are UPM as the project leader, which consists of WIPNet as well as Introp Institute, and we have MIMOS, our IoT partner, and from Brunei we have UTB, Universiti Teknologi Brunei, and Indonesia we have Institute or Universiti Pertanian Bogor, IPB, and BPPT. So this project is from 1st of July 2018 and extended until 30th of June 2021. So the idea is for the three countries, Malaysia, Brunei, and Indonesia, to deploy IoT for the peatland monitoring and management. Yeah, to help and complement the initial peatland management. So the project targets this particular peatland forest in Malaysia. Is called Raja Musa Forest Reserve. My background is in engineering. So before we started this project, we were asking what is the difference between peatland and mangrove. For all we know that there are just hutan paya, right? But in Malay we have peatland, hutan paya gambut, and the mangrove, which is hutan paya bakau. It is totally different. Now I know more and more from my colleagues, from my friends, from Dr. Natra, and from all. So this is something new for us to integrate the technology, especially the IoT and the network, to help monitor the environment. And in this particular project, to help monitor the peatland forest in Raja Musa Forest Reserve. So the project aimed for two main objectives, which is on the technological innovation as well as in terms of social innovation. So we hope that through MEITA, the team can extend the project to mangrove forest, and we can also extend more social innovation, because we feel that the technology without social innovation involvement, it could be just a dry technological innovation. It's not involving with the people. So we want to make sure that our technology, our design, our innovation is implemented, is being taken care of, or being given to the community. Okay, so as we know, this is what happened in 2019 in ASEAN countries. The most left is in Jambi, in Sumatra, in south of Sumatra. This one in Malaysia, you can see KLCC, hazy KLCC in the background, and this one is in Brunei. So we know that this is due to the transboundary haze that happened in 2019, and the composition of peatland forests make it more susceptible to forest fires. It is the soil content is not the same as the normal soil, so the fire can still happen underneath or inside the soil. Even we see nothing on top, we maybe see just the smoke, but underneath is actually fires in the soil. So I start to learn about this, like, oh wow, this is so bizarre. This is not like a normal forest that we can see, like the normal forest fire. So with this unique peatland forest, especially in ASEAN, we proposed this project, and we noticed that peatlands is almost, the majority of the peatland forests are concentrated in ASEAN countries. So we can see here peatlands in Southeast Asia, and then in ASEAN we have and a policy or guidelines to help with the stakeholders, with the government agencies, to how we can better manage the peatland through this APMS, ASEAN Programme on Sustainable Management of Peatland Ecosystems 2014 and 2020. So I guess the relevant bodies are stating they're going to update these guidelines. So in this particular project, we are targeting these two focal areas in parts of research, as well as integrated management of peatlands, because we want to better manage our peatland forests and we want to help the stakeholders. So this project, it is basically the center part of it is the IoT system. The IoT system will be deployed in the site, on the sites, the 3 chosen sites. In Malaysia, we choose Raja Musa Forest Reserve. In Brunei, our counterparts, our colleagues choose Badas, and in Indonesia, they choose Jambi. So in Malaysia, in actuality, so all 3 sites will deploy IoT systems, and then we will integrate the peatland data into one dashboard. We call it NPC dashboard. So we can see, or we can view the data from other neighboring countries within these 3 particular countries, and then we can do some estimation or prediction of potential forest fire in the region. So basically, IoT will be used to complement the manual in situ measurement that has been going on now in each or in peatland forest. So we want to complement, we are not replacing. So we are complementing the manual peatland data collection for a better integrated peatland management. And we noticed that the data, when we deploy IoT, we will have vast amount of data. So these can give potentials for data analytics, big data analytics. What we can do with this large amount of data, we can do estimation, prediction, profiling of soil and etc. So we are looking into this as our technological innovation, but we want also to make sure that the community will benefit from this. Yeah, so we have been engaging with the stakeholders right from the beginning, right from the proposal stage of this project. So we want to make sure that the stakeholders, especially we're working very closely with the Selangor Forestry Department, JPNS, Jabatan Perhutanan Negeri Selangor, as well as MEITA Malaysia, on how we can enhance the project, how we can later benefit the community. And in terms of NGO, we are working closely as well with GEC, Global Environment Center, as well as the Sahabat Hutan Gambut Selangor Utara. This is like a Peatland Friends society. So this is for the data. So we are connecting the three peatland forests in the 3 countries in this project, and then we can share the whatever peatland data that is allowed to be shared. But of course, we will have different levels of access of this data, admin level or researchers level, and then the public level or the stakeholders level. So this is an example of our dashboard. We call it an NPC dashboard. So it is still developing. Our partner, MIMOS, is extending or developing this dashboard so that we can give the access to the stakeholders, then we can view this data remotely. Because now that we are in MCO, because of the pandemic, sometimes you couldn't go to the site to take the in situ measurement on a daily basis. So why not we complement this? They still can go or need to go to verify the data, the peatland data, but they can also view it on a more frequently updated peatland data from their device, like for example from their mobile phone or from their PC or laptop. And we are also looking into potential or possibility of extending this to a MyCuaca app. MyCuaca application by MEITA Malaysia. So we're still communicating with JPNS and MEITA Malaysia, and we really hope this can be extended also to MEITA project. So this is where Raja Musa Forest Reserve is. And this is the tower that we put our weather-related sensors, and these are the swarm areas that we put the piezometer together with the sensors of 3 main peatland data or peatland sensors. For example, the soil moisture, soil humidity, and the main one is the groundwater level. So we deploy it in the peat swarm area, and we were advised to choose this based on the potential or the possibility of peatland forest fire in the area, as advised by JPNS. So this is our deployment of sensors and the gateways. So the sensors is deployed on the ground for the peatland forest sensors, and we also have weather-related sensors on the tower. So we have 2 kinds of sensors, and then we corroborate as well as justify and validate the data between the 2. So this deployment from the site, the sensors deployed in the soil, and then it is relayed to the Lora gateway, Lora gateway here, and then we have 4G communication, 4G signal, and from this 4G, the data is pushed to the cloud. So from the cloud, we can access it anytime as long as we have credentials, login credentials to the website. And this is the weather related data. So we have the ground data, the ground sensors, as well as the weather sensors. So in terms of, apart from the deployment of IoT, we also do some LoRa measurement campaign. So this LoRa is a short or abbreviation to long range wireless communication. So it is one of the access technologies for IoT. It is an open source, it is free basically, because we are using a frequency that is not being used by anyone. So the MCMC, as the regulatory body in Malaysia, it assigned a portion of the frequency spectrum that you can use for LoRa as long as you don't interfere with other systems or with other transmission. So in this particular site, in Raja Musa Forest Reserve, there is no other LoRa transmission, so we are okay to transmit. So we transmit the data, and we want to see how long or how far can this LoRa signal transmit or propagate through the peatland forest. So we did this kind of measurement. And then we see that the propagation, the foliage, the trees, the height of the trees in the peatland forest, they do influence the transmission or the quality of the signal, of this LoRa signal. So we did that last year, and it is still been ongoing. We still have a few more measurement campaigns. And in terms of peatland data part, peatland data analytics part, our researchers, Dr. Sharifah Mumtaza, as well as Dr. Liu, we are working as well as other researchers, we are working on how we can manage or model the data so that we can do some potential estimation. But of course, when we discuss with JPNS, we discuss with our stakeholders, this is good, but we also need some kind of validation, data validation, to make sure that this estimation is validated or corroborated. Okay, so for example, in this particular one, it is the groundwater level. So the groundwater level based on the sensors that we deployed. So how can we tell whether it is in the high risk level? If you could see this, if it is extreme level, high level, medium level, or low fire risk level. So this is what we obtain, the fire risk codes from GEC. So we thank GEC for giving us this information. So it depends on the water table depth in that particular area. So we keep on validating, and because we know big data analytics needs large amount of data, then only you can make good predictions, good or estimation in this particular case of potential forest fire. So we are still working on this. And the project, alhamdulillah, has been very well promoted. It has been covered in the newspaper, and even retweeted by our modesty minister, Mr. Khairi Jamaluddin, and we have a list of updates as well in the web. So the social innovation, this is what I was talking about just now. So we've been engaging with JPNS. So JPNS has been very collaborative with us in sharing with ideas on how to improve and giving authority and approval. Of course, we have to update then on any kind of results or findings that we have. And we also engage with GEC, MET Malaysia for potential integration with MyTracha and FDRS. So these are some of the dissemination that we did. We presented in IGEM 2020 last year. And then there are workshops. We have workshop because the project, not only for the IoT or technological advancement, but it is also for sharing of ideas or technology transfer among the members. So we have workshops in each of the country. So we take turns, Malaysia, Indonesia, and Brunei, to host workshops. So all of us have hosted these workshops throughout the 3 years of this project. And alhamdulillah, we just won the Best Paper Presentation Award in one of the conference that we submitted our papers to. It's called CIIS, Computational Intelligence in Information System. And recently we were awarded with a MTE award, silver award. Yeah, alhamdulillah. So MTE is a Malaysian Technological Innovation Award, and then we managed to get silver from the Lora measurement campaign that I explained just now. So this is the summary of the project. And we have completed almost the end, towards the end of the project already, almost 3 years already. So we hope that in the future we can have this like a potential of using machine learning for prediction, because our colleagues in IPB University in Bogor, they are very well advanced on this. They make predictions of you know, the wind direction, and they can estimate even when and how the haze could reach Malaysia, for example. From Jambi, how long does it take to reach Malaysia in Malacca, for example. So they are very well advanced in this, and we hope that we could learn from each other in terms of research. And we see that these research activities can be better managed and governed under a HAZE, a Trans-Boundary HAZE Center. Okay, and these are some of presentations, publications, and media coverage that you could find if you want to know more about our project. And if I could play the video, Maya or Dr. Natra, do you want me to play?
Yes, please. We still have time.
Okay, let me just share. I think I have to stop sharing first, and then I share the video, yeah? Oops, sorry. Or maybe from your side? But, Maya,
Maya, can you try?
can you try
to
from your
share
side?
the video? Yeah.
Speak up, your Prof.
Okay. Otherwise, I can try from here. Hold on, yeah. Just share.
I try share.
Okay, I'm trying to share now.
Okay.
Can you see it? It's
Yes.
a video.
Yes,
Betul,
yes.
nampak ya? Okay. So I hope you can hear the sound. Can you? Dengar sound tak, Natra?
Not yet.
I'm playing the sound.
But I think there will be subtitles, is it?
Yeah. But without sound, is it gonna be?
I think you have to share the sound itself also when at the moment that you share the screen.
Normally in Zoom you can just tick. But I'll just share nevertheless. Shana, Dr. Natra?
Okay, just share then.
Just share without the sound.
Maybe you can just explain
Okay.
the overall
So,
idea.
all right. So this is where Raja Musa Forest Reserve is. So just some basic explanation on the Peatland Forest.
How big is this forest?
It is quite big. If I were to drive from one end to the other end, it's like 20 minutes.
Ah.
So this is me giving, unfortunately you couldn't hear my voice. So I was on the tower where the weather station as well as the Lora gateway was installed. Yeah. And then this is where we did our Lora measurement campaign. Yeah, this is the area. This is just one part of the area. So that is where the tower is. They're also deploying another tower in another site, which is the 20-minute drive away.
Oh, okay. The tower must be high,
Yeah.
is it?
So the reason, yeah, it's around 40 feet,
Oh,
40 feet high. And we need the, this is the sensors that we deployed on the ground. And this is the Lora gateway. So Lora gateway has to be high up because it has to cover to have good coverage from the sensors on the ground to the Lora gateway. So we stored the data in several clouds, yeah, several cloud servers, one in MEMOS, one in UPM, and one in NICT Japan. So
are there any cases of fires now?
not anymore. The last one they had was in 2014. So it has been quite well taken care of. They do have a few just recently in 2020, especially during the MCO, during the pandemic. But it was under control. So this is the weather station as well as the Lora gateway. So weather station has all those temperature, rain intensity, humidity.
And so far it worked well.
Yes, we do have some challenges, especially in terms of again during the pandemic, because we couldn't go there in person, and we noticed that the data that we received was quite erratic. So we've been identifying why is it like so different, like the data from January, February, for example, with the data in June, July last year in 2020, and then when we managed to go there, we noticed that the sensors were actually being pulled out. It's not like it's either the wild animals. For example, that area is quite famous among wild boars, but it could also be because of the rain, and then there was a drought, and then rain, and then drought. So the census, maybe it was inserted quite well indeed, but sometimes because of this change of weather, it goes out from the location. So this is our partner from MEMOS, Dr. Nordin. They are responsible in developing the NAPC dashboard using their platform, My Mr. MEMOS. And the dashboard is integrating data from the 3 countries, Malaysia, Indonesia, and Brunei. So the challenge here in terms of data and when we want to put it on the dashboard is data governance, because some countries, they may not want to share their peatland data. So we have to make like proper deliberation with the stakeholders, and we tell them that this is purely for research purpose, and we have levels of access, the admin level or researchers level, the stakeholders level, and the public level access. And this is Mr. Hasmi from the forestry department. So he was telling about how the Aduwati could help the forest rangers, because in this area, the forest rangers are collaborating with the GEC, and Sahabat Hutan Gambut to get the in situ measurement.
Then we need such tower in Sijangkang also, is it?
Yeah, that was what we've been discussing with our vendor. We noticed that there is one light pole. Yeah, light pole in that area. I think it's just recently deployed, but it is not far. It's not tall enough because it has to be higher than the trees. Taller than the trees. So that is the main challenge, because we want to get line of sight. So in Lora, the access technology that we choose for this IoT deployment, it has to be line of sight from the transmitter. Transmitter is the sensor on the ground to the Lora gateway on the tower. So that is one of the main concerns that we have to face in Sijangkan. Okay, that's all. Thanks a lot, Dr. Natra and all. Sorry for the audio problem.
Thank you, Prof. Adu, for the nice presentation. I'm
you.
glad to see that your project worked very well for the peatland. I hope it will also work well for the mangrove later.
Yes,
Okay.
inshallah, inshallah. Since we have some experience now, so I think we can better manage this time.
Okay. All right. So let's move to the third presenter. So we have here an expert on robots, Associate Professor Dr. Ahmad Athif Muhammad Faudzi from Universiti Teknologi Malaysia. So let me read his biodata. So Dr. Athif, he received his Bachelor in Engineering in Computer Engineering and also Master in Engineering of Mechatronic Automatic Control from University of Technology Malaysia. And also he did his PhD in Okayama University in Japan from 2004 to 2006 on system integration. Okay, he was a visiting research fellow at the Tokyo Institute of Technology from 2015 to 2017, and from March 2019 to date until now, until present, he is the director of the Center for Artificial Intelligence and Robotics, or also known as CAIRO, and he is mainly engaged in the research field of actuators, concentrating his work in the field of robotics, bio-inspired robotics, and biomedical for biomedical application. He is a professional engineer. He's also a member of IEEE Robotics and Automation Society and a member of 2 Academy Science Malaysia Special Interest Group of Biodiversity and Robotics. He was also recipient of Top Research Scientist Malaysia in 2020 in the area of robotics. So let's hear about robots now. So
Okay, thank you very much. Dr. Adra, can you hear me?
Yes, clearly.
All right, okay, thank you very much. So we had a good presentation by both of the previous speakers. Thank you very much. And I also learned many points taken, mentioned by both previous 2 speakers. And next, we are going to go through some of the different aspects of technology that we can bring in together for mangrove, especially in biodiversity per se. Thank you again, Dr. Natra, for a nice introduction. So in our MEITA project, we are under the MEITA Robotic Group, and I'll be a little bit on our center. We are from Center for AI and Robotics under UTM. We have 2 offices, one in JB and one in Kuala Lumpur. The center was founded already 20 plus years ago in 1997. And now we have 9 members, 5 in JB and 4 in Kuala Lumpur. I'm in JB, actually. Our center is doing a research area, trainings, consultancies in the area of AI, robotics, and control. And agriculture is part of the area that we are involved in. So I believe our involvement in this MEITA project is very, very good, that we can also learn in different kind of areas as well. And in myself, I am working in the areas that what Prof. Natra was mentioned, bio-inspired, rehab robots, free robots, and now I included one more area of biodiversity. So we have underwater projects that we are working on, and currently, just recently, we went to Tanjung Tuan and do some observations of underwater creatures, corals, including we found manta and also turtles. So in more detail, we are working in the fundamental aspects as well in these areas as highlighted in this box. These are more detailed projects that we're working on under the 4 main areas that I have just mentioned. So let's move on to mangrove and some of the technologies that we can discuss related to AI and robots. So this is a picture taken not by our handphone, not by our DSLR camera. So this is an eye or a view that was taken by drones. And currently drones are being used mainly in taking images, pictures, and also videos like what you can see now. This is a drone aerial flight video that was taken in Langkawi. Okay, so this is not from us. So there is one trademark here, taken by one, professionals on the area of mangrove. So you can see the beautiful landscape of Langkawi area. This is in Malaysia, by the way. So as what mentioned by Professor just now, the first speaker, regarding the beautiful images and also scenery that we can get through mangroves. And here we can see that the flora and fauna, from the top we can just see the tropical view, but under the area we can see more and many creatures, crabs, and as what Prof was mentioned just now, and mollusk creatures, fishes, and so on. So these are part of the thing that we can go and look through in the specific area that we are working on under MEITA in the area of Sijangkang. So in the robotics side, we can see that it can also be working together, not only under the hardware part, we can also integrate it with AI. So AI stands for artificial intelligence, or in Malay we call it as kecerdikan buatan. So what AI can do? So this is an example of how, if we can see from this picture before I play, so we can see that in this picture there are people, mainly people who are moving, and then we have the background area. Maybe this is in shopping mall or somewhere with open space. But then as the people is moving, so AI can do detection, okay? And we have people who is not moving, so it doesn't detect. And from here, we can also use AI to do different kind of things. So detection is one thing, object counting is another thing. So this is another example of how AI can do things that we can do, but within this very fast time, okay? So we cannot even count how many cars moving from left to right and how many cars are moving from right to left. So this is something which is very, very interesting, that how we can utilize AI together with different kind of technologies that is available. As what Prof. Adu was mentioned, how AI can be used to do detection, machine learning for haze, and many other kind of applications. And we can also utilize AI for object recognition. This is different from counting. So here we can identify, for example, how many cars. How do we recognize the differences between sizes? Maybe now even AI can do recognition of types of cars. For example, we have Honda cars, Hyundai car, Toyota cars. So this is how things that we can do after we go through our car catalog, right? But then in AI, we have to do the same thing. Okay, we have to learn from multiple data, and from there it will be more accurate. So based on this, we also can integrate AI with robots. Okay, so for example, this is a robot that can be thinking by itself on where to land. So this is a drone. We have the area. So then the area will be given by the camera feedback. So from there, the drone can automatically go to any area which have H signs and do its landing automatically, okay, without any intervention by human. So I would like to share some of our research by our CAIRO colleague, which we use deep learning and AI with drones. And this is example from a research by Dr. Zol. He's from CAIRO. He's working on deep learning sensor fusion in plant water stress management system. So having drones to be flying around, we can also collect data and also do some reporting based on cloud data that we have. And we can also utilize drones, for example, with low altitude quadrotor for plant growth monitoring system. So for example, now it's in April, right? So in April, we can do a survey using drones, and later on in June or July, we can see what are the differences between the type of growth of the particular tree or mangrove area that we want to study. So this is possible to be done by using quadrotor. by using drones as well, there are many other areas that we can explore. For example, we can do for asset management, we can do for counting animals. And this is an example of how AI were used. So just now I've shown how we track for cars. So this is how we track for cows, okay, and count them. So using drones, we don't have to go and count one by one. Sometimes we even confused by ourselves. Have I counted this animal or not, right? So for drone, we can do it directly and using AI to identify which animal that we have counted and which we haven't counted, right? And this is another area that we can also use to detect diseases of paddy. So this is something that was done, and also to identify how many fruits that was covered by bags and how many fruits are not yet covered. Okay, so there are green boxes which shows the fruits covered by bags to protect it from animal or maybe from other, to have a better growth, and the one which is not having the bag. So this is some of the study that we can do. So this is another one of using drones and AI to monitor asset. Okay, so this is example of fences available in one area. So it will be taking time for us to go to do it by foot. Okay, because we have to go very closely to the fence. Even we can see here by our own bare eyes, it's quite difficult to identify whether this is still okay or not okay, right? But then using drones and with a good frame per second algorithm that we can use, so that we can do and detect the functioning or non-functioning fences. Another study that was conducted by our colleague is to monitor water quality, but then it is monitored by algae observation. So from images, we can have this molecular identification, and from here we can utilize AI again, do some comparison with the data that we collect, and computationally we can have the water quality index, environmental index, and also the preservation for biodiversity that we can do. So other than flying robots, okay, under MyLab, we are working for robots. So initially for MEITA project, we proposed some of the underwater systems that we can use. So this is example of a robot that we utilize it for cleaning actually. So how it is working like a vacuum cleaner, but then it's working and operated underwater. So we can do this not only for cleaning, we can do observation for areas. So maybe if it is not suitable for mangroves, we can use it for aquaculture, or maybe some other areas that we can do for cleaning. Okay, so not only pool cleaning, tank cleaning. So maybe we can look for the agriculture as well on this particular technology. And we are working also for a new upgrades of the system, as well as applying some of the autonomous functions with underwater sensors. Okay, so this is part of the thing that we are working currently. And at the moment, we also have this another robot that, okay, by the way, we have the previous robot we call as ROV Pleco. So Pleco is the name of ikan bandaraya. I think for those who are fish lovers, so biasanya akan ada aquarium, so we have to also beli ikan bandaraya to clean our area of aquarium. So that's where we get the name of ROV, and we put Pleco. So for this one, we call as ROV angler. So angler is a deep sea fish that can it have a bulb by itself. So this is a very different creature that we cannot see easily. And we take this name for the ROV that we are working now under a collaboration with SUK, Medivest, WWF, and also some other Department of Fisheries as well to do observations for underwater. So this is example of one of our site work that we do in MMHE to observe the installation of a dock gate, and we utilize ROV to identify the position of the hinge, and we also observe some of the creatures underwater during that time. We were interviewed by Adiba, and I don't want to go through that detail. So here we highlight the two of the projects that we have, and then we bring Adiba and show her how the system works. And we show her the demo, and she can control the robot by herself. So this is very, very easy. So that any people can also use this to control. This is like underwater drone, what we call. And this is one of the things that we utilize it for. So currently we are working with Department of Fisheries to use AI with the robots to detect turtles. Okay, so corals, turtles, and other underwater creatures is something that we can use to do and work together with AI. Okay, I understand that the time is very limited, so I would like to go for, this is a mobile robot that we are using, and I'm not sure for agriculture how we can utilize this. One of the plan now is to do planting. So either we can use a mobile robot like this, or maybe we can utilize it using drones. And this is an example of a demo that we use for doing inspection in a small and confined area. So and we try to utilize a wireless and also use a platform, for example, by using your phone to control it easily. And under MEITA Robotic Group, currently I'm working together with our RO, Mr. Wilson. So we are working for promotional and educational activities, hopefully in the initial stage. And then for the extension plan, we can do on the drone and applications with the robotic part. So we want to see the focus is on using drones and to have aerial map and to pinpoint where and how the condition in Sijangkang, and to determine the conservation properties, to highlight beautiful environment scenery of mangroves, so that other people can also know, not only for school, but then for the whole nation for this MEITA project. And in the extension plan, we try to apply some of the computer visions, AI part to do even for exploring seedling area planting. I think that's all from me. Thank you very much for your kind attention. So I have a very limited time of 15 minutes. I take extra 1 minute. So over back to you, Dr. Natra, for the next session. Thank you very much for your kind attention.
Thank you, Dr. Athif. We can see you have quite a number of robotics projects there, but one caught my eye, which is the algae part. I didn't know that you're working with algae too, and I think that
is something that we are working with Prof. Dr. Ibrahim under CAIRO. Yes, so we can connect it together with some of your work, Dr. Natra.
Yes, and I think that is a good, actually algae is also a good indicator in mangrove ecosystem. Prof. Faridah here on the audience can elaborate more, but we'll talk about that later, okay? All right, okay.
Yeah, sure. We have few questions here, but then I think we can discuss from Hazel.
Okay.
Yeah, later on. I think we will do this on the panel discussion.
Yes. Okay,
yeah,
let's
Hazel, thank you very much for the question.
All right. Okay, next presenter is Dr. Evelyn Lim Aileen. All right, so she'll be presenting on the socio-economic part. So let me briefly introduce her. Dr. Evelyn is a senior lecturer in the Department of Nature, Parks and Recreation, Faculty of Forestry and Environment, UPM. She has been working in environmental education and community-based program as a practitioner and researcher for 20 years. I think you're still young. Okay.
Thank you.
Her interest is in exploring what works and does not work in developing and implementing effective programs, specifically designing programs and developing modules for teachers and students based on the principle of interpretation. So, Dr. Evelyn, the screen is yours.
Okay, thank you, Dr. Natra, for the introduction. Salam sejahtera and greetings to everyone. And thank you for the opportunity to share our work in MEITA project, focusing on socio-economic matters. Yeah, all right. So our team consists of the members, as you can see on the slide. Yeah, we have members from the Faculty of Forestry and Environment, which is myself, as well as Dr. Sheena Bidin. From the Faculty of Agriculture, which is Dr. Isharuddin and Dr. Rozihan. And from the Borneo Ecoscience Institute, UPM Bintulu campus, we have Prof. Datin Dr. Farida Hanum Ibrahim as part of the team members. Yeah, all right. So, aptly, very aptly, the theme for this year's Earth Day celebration is actually Restore the Earth. We cannot really deny the fact that conservation is not only of its resources, but it is also involving its people, because management of its resources are actually by us people, specifically communities in its vicinity. Hence, the MEITA team for socio-economic has focused on our initiatives to capacity build the local communities towards mangrove conservation initiatives at Taman Rekreasi Paya Bakau Sijangka. And with us today, I would just like to introduce Encik Fazrin Rohali, who is one of the local committee with us in this workshop. Yeah. Now, just let me bring you quickly, to this park. And historically, like what Dr. Natra has introduced, the mangrove at this area has been used as a dumping site. It is pretty common perception that wetlands are wastelands, right? But realizing the importance of the mangroves to the local communities, the fishing communities and the small industries, and the potential of developing the park for people to enjoy nature, especially the local communities, the people themselves residing around the mangroves have initiated cleanup activities and awareness programs to encourage local communities to keep the mangrove clean. In 2015, the Taman Rekreasi Paya Bakau Sijangka, which is the name of the park, was established with the support from Kuala Langat District Council. So the park is actually managed by an NGO, which comes under the purview of the local communities. Yeah. So the park is established mainly for research and education purposes. Hence, it is no wonder that a majority of the visitors consist of students ranging from preschool kids right up to higher learning institutions, going there, experiencing the mangrove, conducting research, and learning about mangroves. Yeah. So one of the interesting main attractions at the park is this 750 meters long boardwalk. That's just one way that extends to the Straits of Malacca, which enables visitors to experience the various flora and fauna in the mangrove. So along the boardwalk, you'll be able to see these facilities, resting areas, either in a form of sitting area or wakafs, because many visitors go there for leisure activities, just to be with families and friends among the locals, all right? And then there are also many signboards, remembering that the history of this site, that it used to be a dumping site. So there are many signages along the way, just to remind people to keep the mangrove and the park clean. All right. And besides that, we also have, for those individuals going there for a self-guided tour, you can actually access and gain information on mangroves using this one-touch QR code application, which was developed by researchers from Institute of Tropical Forestry and Forest Products, UPM. All right, so you can just use your phone, snap the QR code, and you'll be able to access the information online or offline. Yeah. Besides that, they also have facilities, for team building activities, and this is also very popular among students of every age. Yeah. And then they also have, information boards at the Medan Ilmu and Sudut Ngobrol, and just to share on what mangroves are there, what have they been doing, their achievements, yeah, to share with walk-in visitors. They also have set up a nursery, and they also have a stingless bee project, which they work together with the Kuala Langat District Agriculture Department. Okay, so based on these slides done, it is really no doubt that the local community under the present leadership of Encik Suhaimi Sanusi has been instrumental towards the conservation of mangroves in Sijangkang. So what else is there for MEITA to do there if they are already so good? Okay, so to ensure that we add value, the MEITA project actually adds value to the initiatives of the local community. We hope through our activities we'll be able to support and extend their initiatives, especially beyond the team of active volunteers we have for the park, through capacity building the local communities to participate actively in conservation initiatives. Yeah. Now, to understand how the project could support their existing initiatives, we actually had a discussion here with the local community and found that these to be the needs, yeah, for improvement of the park. Yeah. Generally, they feel that they are lacking in information and understanding on the mangrove ecosystem, particularly in terms of the ecological functions, roles, and scientific information, yeah, of mangroves. They also feel that they are facing lack of resources and skills because most of them, the active volunteers, are volunteers who actually assist in the park during their free time, and many of them do not have formal trainings in organizing and conducting programs and activities. And another is a need for a succession plan. Why is that so? Because at the moment, there are approximately 20 to 30 volunteers who are actively doing conservation work at the park, but then they are mostly between the ages of 40 to 60 years old. So what happens, in the next 10 or 20 years down the road? That's a question, yeah? All right. So based on these desired needs, we have focused the group, yeah, our socio-economic group have decided to focus on two major activities to ensure we are able to provide a meaningful and effective process of capacity building the local community. And it involves working with schools in the vicinity to engage them as volunteers, yeah, for the park, and also to develop an augmented reality of recreational fisheries in Taman Rekreasi Hutan Paya Bakau Sijangkang. Now, although the team, the socio-economic team has planned for a training program to enhance adult volunteers' knowledge and skills in developing and running recreational programs for corporate sectors especially. However, they have requested that maybe we put this on hold until the adult volunteers are ready and at a better time. Yeah. So for that, we are only focusing on these two activities for the MEITA project. So what will we be doing in these two activities? Yeah. So working with schools in the vicinity to engage secondary school students as volunteers. One is actually to provide opportunity to groups of interested students to be environmental volunteers. When we ask students, have you been a volunteer? There will be students saying yes. So what kind of volunteer work do you do? Oh, it's a lot of this volunteer work is associated with social contacts, yeah, volunteering in old folks' home, in mosques, yeah. So these are the things that they actually do. But then in environmental, being an environmental volunteer, it is rather limited. And if there is an interest, they would ask, how do I do it, and where do I go? Okay. So this program is actually to provide that opportunity to interested students to be environmental volunteer and to experience what it is to be an environmental volunteer. This program, it is to provide students, through the journey as a volunteer, the needed knowledge and understanding on mangroves, and how they, as students, they can add value through their volunteering initiatives, And finally, it is to give students the opportunity to be actively involved in the program by allowing them to develop and implement the volunteer program activity. We actually did this with a group of students. You will see the group of students in this picture in Perak, where we allowed students to develop their own volunteer programs and activities based on the initiatives or the aims identified by the local community and matching that with their interests and their ability. It was very interesting to see that the beginning was really a struggle because it was a struggle for students trying to match whatever they want to do and what they know they can do or what they know people have been doing to the aims. Okay, so there was a lot of mismatch, but that experience was very, very important because that really enriched their volunteering experience and enhanced their ability to make decisions. And that process itself is very, very pertinent towards capacity building of communities, students, adults alike, towards making sustainable decisions. So what do the students do? Very simple tasks, okay? Because we know not everyone is into mangroves. Not everyone is into getting sweaty and hot under the sun. Not everyone likes to get dirty. So, okay, if you are skillful in any way, for example, in drawing, let that be your interpretation and sharing of your message through painting or drawing. And if you are one who is very creative, let that be translated through the teaching materials you develop to teach other children about the environment. And those who are into science, that's where you actually harness your data collection skills and analysis. And for some who are really into who has the people personality, that's where we actually mold them to be facilitators and to be guides, to share the message with their friends, peers, and even parents and adults and teachers in schools. So what are we going to do for this program? So for this social economic group, we see ourselves as gelling, all the components in this MEITA project, gelling the groups from the IoT, from the robotics, from the biodiversity, and getting all these teams to work together with the students for us to get information on the mangroves, which will be used to share through their various media platforms, which the students themselves will be the main driving force. And it is also an opportunity for us to reconnect the students to the culture and tradition and the livelihood of the local community there, with the environment. The community there are mainly of Malay Java, and they have very rich culture. So it is very nice if we can bring these students to reconnect back, and to understand how the various arts and culture and traditions have actually evolved from their very environment, which is the mangroves. Okay, and finally, we also hope to develop a recreation team where this group of students would be trained as facilitators, and they would be assisting the adult volunteers, God willingly, to conduct activities and at the park. All right. So these are what we will be focusing on. Very essential elements for us when we do such volunteer programs, and especially in terms of school students, to maintain their motivation, to maintain their excitedness to be continuously involved. Because when you capacity build a community, it is not just a one-off. It is not so much about just gaining knowledge, but it is beyond that. It is the personal development. It is the relationships. It is the journey, the ups and downs that you go together, and that would actually enrich the person, the individual and the learning processes. So very important element, it's explore the environment, to reconnect back with the natural environment, especially this movement control order. But however, we have to wait for the right time, for them to gain experience, and inspiration from their natural environment. It is so important to play together, to play together, create memorable experience to enjoy, because that will actually sustain the motivation for them to be continually being a volunteer. The journey of being a volunteer is also very challenging, because they need to learn to embrace and deal with the differences. They may be from the same school, they may be of the same age, they may be from the same village, same residential area, or even the same house. But each of these individuals are very different, because they have different knowledge and different life experiences. And that itself, it is a challenge, and this is a very rich learning experience. It is a very essential thing for them to know that lots and lots and lots of communication and discussion is very, very important, because I think in our Asian culture, we are rather reserved in terms of sharing our ideas and our opinions, for fear that we may offend one another, or our ideas may not be accepted, and so on and so forth. But they have got to learn to be able to work together. It is about communicating, discussing, sharing, and being open to one another. Making decisions, very important learning process in capacity building of local communities. If they are not able to make decisions, and decisions are made for them, they will never ever learn how to make right decisions. And making mistakes, no big deal, because that is where the whole learning process begins. But it is very important that the role of the mentors to always help students to reflect on this journey and processes, the failures and the successes, so that they'll be able to understand what the journey really means. And for the mentors, the adults, it is very important for us to learn to listen to the younger generation, to be open to their thoughts and their ideas. And when we are open to their thoughts and ideas, sometimes we'll be very amazed at how creative and how much they have to offer. And another important point is also acknowledge and celebrate their achievement and success. They are just like us, we want acknowledgement, we want people to appraise us for our achievement and successes. And yes, and in this program, what we did was we brought the group of students, for an international conference, where they actually shared their journey as a volunteer, their failures, their successes, how was the journey like, the sweet and the sour, all in one. And the good thing is that, they were so motivated when the international participants were so acceptance of their sharing. And that itself was enough to sustain their motivation and kept them coming over and over again. And in fact, that very moment changed many of their lives, because this girl, after this event, she was practically asked to be the MC for all major events in school, including state level. So there were many life-changing experiences from these volunteers as a testimony. And so that is the story of the student volunteers whom we hope to replicate in this group. We know that we can replicate most of the processes, but we need to adapt yeah, because scenarios and situations may slightly differ in Sijangkang. So that is the student volunteer program. And for our second activity is actually the augmented reality of recreational fisheries in Taman Rekreasi Hutan Payu Bakau Sijangkang. And this is actually led by Dr. Izharuddin and Dr. Rosihan. Yeah. So it is one of the methods to promote mangrove areas, especially for tourism and other recreational activity purposes. Yeah, because there is a river that is passing through the park, but there is no fishing activities at the park. So, which is actually very good. So, and this augmented reality is also to verify the possible ways of promoting the activities that you can do at the mangrove park virtually, yeah, and sustainably. So with the presence of the augmented reality on the map, you know, and also on the signboard, so the mangrove area at Sijangkang can be viewed and seen anywhere around the world. And this idea was a lot inspired by the COVID-19 pandemic, where all of us were locked down and hunger. Yeah, we were so hungry to actually go out in nature. Even virtually, that was just enough to satisfy our hunger. So what we will be doing with the local community is the team will be organizing workshops with the local community to teach them a step-by-step method and techniques of how to develop an augmented reality and 360 views in a mangrove area using recreational fisheries as one of its first trial activity. In the hope that after this, you know, the local community can actually develop many more activities virtually as a promotion effort of the site. This is an example of the augmented reality on the map, which will be developed, all right? And embracing, yeah, embracing the spirit of Earth Day, because Earth Day celebration was made possible because the people drove, you know, and came together to celebrate Earth as what it is. So I would like to end this session with, we shall never doubt that a small group of thoughtful, committed citizens can change the world. It may be so insignificant to one, but nothing is ever insignificant to Mother Nature. It is better to do something than not doing anything. And indeed, it is the only thing that ever has, from Margaret Mead. Thank you very much.
Thank you, Dr. Evelyn, for such an inspiring talk. We really look forward for your, initiative with the students of Sijangkang and also this augmented reality. All right, so now we have come to the panel discussion session. So we have a number of questions in the chat box, but I would also like to welcome if there are attendees who want to basically speak directly to the speakers. You can just raise your hand, and then and from there you can unmute your mic and just say loudly what are your questions are. But first, I would start with the questions in the chat box. So we have question for Dr. Athif. The first one is on whether
counting, yeah.
Yes.
From maybe
Small
from
microorganism.
Hazel
Yeah.
Monica, yeah. Okay, I privately email reply, but then maybe it is related to some of other question related to AI. Okay, so how AI works is like how we use our perceptions. Okay, so if we have our sensory of eyes, nose, ears, touch, and then we do collect data of, for example, if I want to identify whether this is a pencil or this is a pen. So because of the data that we have learned throughout the years, then we identify that this is a pencil. But if we want to go through a different kind of objects, for example, to monitor zooplankton, so we have to identify what sort of zooplankton that we want to see. Can the secretariat give me the sharing capability so that I can share examples of the images of what we took with our ROV? Our camera is around 720. Okay, so I can share it now. Thank you very much. Okay, so this is example of the images, the other images that we saw. Can you see the pictures? Maybe I can enlarge it a little bit. So other than looking at the hinge, which is exactly going in through the part that they want, we also observe other kind of barnacles, soft blobs. So this is like obo-obo, and then I don't know, maybe I don't know what kind of creature is this. And some of the fish as well as stones, maybe experts may know in more detail. So the soft blob, so these are the range of image that we can see. But due to the quality of water, which is not as good in the area of Pulau Sipadan ke ataupun Kudat ke, so it's quite difficult for us to identify. So maybe the range of image that we can see is very, very near, and therefore, although we have a good camera of high definition, full high definition, but then because of the water quality, it's quite difficult as well to see. But this can be improved with some of the algorithms. Okay, so if our naked eye couldn't see, so it is something similar with the quality of the camera as well, as whatever good quality of camera that we use is quite difficult and challenging and quite challenging for us to detect. And again, if we want to identify, for example, this kind of soft blob and do counting, so we have to train with hundreds of data. So then later on we can do counting, and then we can do the study of the accuracy. So hopefully that is answering one or two of the question. So I may stop the sharing. And somebody was asking about the accuracy. So the accuracy is depending on how large the data that we can obtain. So for example, we are working with turtles at the moment to detect and identify different kind of turtles. So we have hornbill turtles, ada penyu kara, ada different kind. I think if I'm not mistaken, there are 4 main types of turtles in Malaysia. So we have to identify looking at the paruh dia, and then the shell pattern, and then the material of the shell. So until that level, we need more and more data. So then it will be translating to the accuracy of the subject. Okay, Dr. Natra.
Okay. I think we also have question for Prof. Adu here. Wait. I saw just
Yeah, related to the hardware and network.
Yes.
Yep. So the question from Sharafis Rahim, right? Thank you, Sharafis, for asking. So it is on the consideration of hardwares or network in regards to the changing environment and climate. So just to share you some experience when we were deploying the IoT system in Raja Musa Forest Reserve, when we noticed that there are some erratic data that is not validated with the real data. We see some errors, like some difference in terms of the real data as well as the IoT system. And we've been thinking that what went wrong, because the Lora system is okay, the cloud server is okay, the Lora network there is good. But when we go there, we notice that the sensors, the piezometer that we deployed in the soil or in the ground is full of ants. The ants in the peatland, and then we noticed that another one, that the sensors being pulled out from the hole. So all these issues, it's not basically with regards to the hardwares or the network. The technological part is good. We can say that it goes as what we planned and designed. But the real challenge, I think, in my opinion and from my experience, is the sensors on the ground. That sometimes we have to purchase the sensor that is marine grade, for example, for the Sijangkang area. We have to buy sensors that's marine grade so that it won't degrade easily or quickly. Or for example, if we want to deploy it in the peatland areas, then probably it should also be marine grade, or maybe a sensor that is the sensor is enclosed, yeah, with an enclosure or cage, so that the wild animals or it doesn't fall off easily. So I think that the challenge is more on the deployment itself, but not on the technological part per se. Okay, Dr. Natra, thank you.
Okay. All right.
Sorry, I think there is also another question by Hazman. I simply typed, but I can explain if it is allowed, Dr. Natra.
It's okay, of course.
Yeah, okay, thank you, Hazman. Hazman is my student actually. I asked my students to attend this webinar. So Hazman was asking about the transmission from the Lora gateway to the cloud, right? If I can scroll up, yeah, he was asking about the transmission from the Lora gateway to the cloud, because Lora, it transmit in line of sight, meaning that if there is an obstruction, yeah, or obstacle, the transmitted signal will scatter. So the received signal is not as good as what is transmitted. So in that sense, when it is line of sight, and in particular because the peatland trees, it has a certain height, so sometimes it get scattered and we get poorer quality of signal. So it goes more or less when we test around 200 to 500 meters in that particular peatland area. So we will do the same in Sejangkang, in the mangrove area, how far the signal can transmit or propagates. So from the ground sensor to the Lora gateway, we use Lora, but from the Lora gateway to the cloud, we use the normal mobile communications, mobile data. So in fact, we use the SIM card in the Lora gateway to transmit to the cloud. Okay, that's all, Dr. Natra.
Okay, I actually have a question for Prof. Farid. Prof. Farid, since you are a mangrove expert, how do you think IoT and also robotics can help in terms of mangrove management?
It's the first time that I'm involved in a robotics project. To admit that the most technological we get is by flying drones. We also fly drones, but basically to just look at the spectral signature of the trees. We've never tried to identify the trees or moving things. Can be debris, for example. Moving debris would be very interesting, because debris is also accreting propagules. That's something that I think of. But otherwise, I have to think about this. I have to see still the integration, because every part in itself is very logic and seems to be very promising. But then how practically to do something that can be of immediate use for the management, that we actually need to discuss amongst ourselves also about this.
Right, okay. So we will have our discussion soon after this. All right. Next, there's another question for Dr. Athif. Can you please explain further on how AI work with algae?
Okay. Can you hear me?
Yes, yes.
Okay, hold on. Let me share back my screen. Yeah. I missed the slide already. Yeah, I open it back. MEITA. Okay. So for AI for algae, this is depending on the because okay, we have this issues in UTM as well, because there are our tasik, our pond in UTM that was affected by algae. So what happened is we have a lot of I don't know what they call it, some underwater plants. It grows and then it is filling the pond with this, maybe because of the quality of the water, which giving more growth value for the underwater per plant tu lah. So what we did, the survey, so we have drones to identify, and based on that one, because this project is actually the leader is Dr. Ibrahim, and Dr. Ibrahim is one of our main member in CAIRO for AI research. So I may ask him in more detail based on his identification, because currently for water quality index, as what I know, we have to do and identify based on many parameters like DO, and then the BDT, the salinity, and there is some calculation that being used. So in terms of using AI and also doing this study, there are some algorithms based on the study that was conducted by Dr. Ibrahim. So I don't know that particular algorithm in detail. So if I may get your Prof. Jamal, your contact, then maybe I will be asking the information from Dr. Ibrahim, and I can send over to you, inshallah.
All right, thank you. So any other
Okay,
questions from the attendees? You can also unmute your mic and ask directly to the speakers. May I know from the speakers challenges in your field? For example, like Prof. Farid, what are the biggest challenge when you are working, related to your field?
And you are referring to all countries in general, to Malaysia in particular?
In general, or you have challenges when working with Malaysians?
Not with Malaysians, with the Malaysian government. That's another another issue. No, I think that my biggest challenges in Malaysia is to obtain long-term trends, long-term data on management of the forest. I know there are very big research institutes like FIM and like of course the forest department itself, but it's very hierarchical. So even public documents which you can find in a library anywhere, if you ask them by email, one has to ask the authorization to his boss and his boss and his boss for a public document. So that doesn't really make sense if we're trying to get data for long term. Otherwise, for mangroves in general, and I think it's Malaysia as well as other countries, is to I think a little bit what Dr. Evelyn said also, and which I emphasized also in my speech. From an early age onwards, to start having this switch in your mind about the goods and services of mangroves and what the mangrove forest means to us and gives us as ecosystem services. And very often, short-term benefits outweigh the long-term benefits for the people in their minds. And so almost everywhere, if you have to choose between a quick cash-generating aquaculture pond and a mangrove forest, which will take 10 years to generate the same kind of money, they always go for the short term. And we can see it in Malaysia, for example. It is the oil palm, oil plantations, which are really, how can I say, encroaching on a lot of mangrove forests. And I think that state of mind change of looking at the long-term benefits, which for all clarity outweigh manifold the short-term benefits. So it's only the term which changes, but the artisanal fisheries also, for example, outweigh much more the industrial. I think that state of mind change, that's a big challenge.
Okay, thank you. How about you, Dr. Aduwati?
You mean in terms of challenges?
Yes.
Yeah, I can talk apart from the deployment deployment challenge. I think from a network point of view, it is theoretically and technically feasible, especially to transmit IoT data, any kind of data, environmental data, peatland data, or later in MEITA project we have mangrove data. It is feasible, but from engineering point of view, we have to do the site survey, and we have to identify the plan on where exactly we are going to deploy the sensors. And for all we know, we just know what sensors to deploy, but the subject matter expert is people like you, Dr. Natra, like you or Dr. Evelyn. Yeah, Prof. Farid, what exactly is need to be measured to monitor the particular area, the particular site. So this is where I think not a challenge, but actually it's an opportunity for us to work closely in terms of multidisciplinary area and project. Okay, thank you.
How about you, Dr. Athif?
Okay, thank you very much, Prof. Natra and all for the session that we have today, a good discussion session regarding challenges in applying robotics and AI solution. Again, it is very related to what Prof. Dahdouh was mentioning. We have to talk to the subject matter experts because from our side, we have the technology to use, but then in terms of the actual needs, even in our MEITA project, when we started to suggest of using underwater robot, it was not clear how this underwater robot can be serving the purpose of studying in putting the robots underwater to maintain. Is it going to go and getting the dynamic data? So as what we have discussed today, I can see that some of the studies that we can also do is to utilize the robot going to a certain coordinate or area, and then we can go and take the samples at any depth that we want. For example, we go and take samples at this depth, because for human to go down, so maybe it is not accurate. I don't know. There are some accuracy part that we can also debate. But then using robot that we have sensors that we can identify the location and so on, so we can get at that particular levels of depth. This is actually something, some practical, I mean, the actual practitioner, maybe they have this kind of method that we can also make it as an alternative by using robots. So the question just now in our chat box asking about how AI can do and help, we can also utilize robots to do the work on getting the samples, and later on we can do the study in our lab and utilize AI as well in different environment. So that is some of the challenges, and I think the communication is part of the important point, understanding our different background and then work together, as well as looking at the needs from the stakeholders. So I think that's all from my part, Dr. Natra. Thank you very much for all the attendees and the people who are asking questions.
Yeah, we are very fortunate in this MEITA project. We have all sorts of people, scientists, researchers from different background, especially the mangrove experts. We have the ecologists, the aquaculturists, and not to forget the technology people, you and also Prof. Adu. Okay, all right. Next, how about you, Dr. Evelyn?
Okay, I think there's one question for me with regards to the AR launch. Actually, just to answer Sufu, we have not quite decided yet, but more likely it will be through the web because it's something more feasible and easier for the local community. But launching it through the app may be the next phase for us. Yeah. I would just like to go back to what Prof. Farid said about, mangroves and crocodiles. I did a study in Malaysia, getting what students think about mangroves. And it is very true. It depends on where they are from and what is their social culture. Yeah. In Borneo, yes, because there are many cases of human-crocodile conflicts. So yes, there is a negative perception. Oh yes, yeah, mangroves means crocodile. In some areas, it is more of mystical, because they associate with the roots, the steep roots, which looks very odd and unappealing to the eyes. So for them, it has some mystical beliefs in it. Yeah, so it really depends where we go and the community that we go. Yeah. Yes.
Okay. All right. Nice to know that. Okay. We are 5 p.m. in Malaysia now. I just want
Dr. Natra, I think there is one question for Dr. Evelyn by Siti Aisyah Razali in the chat box.
wait.
The last question.
All right. Okay, institution of pandemic right now, most probably the effort for eco education or forest education focus more on the online based program. How do we adapt to it to ensure that we can continue empowering the community for sustainable ecosystem, as we know it's quite challenging compared to face-to-face method?
Yes, definitely. Even for this year, for the implementation of this project with the schools, we had to switch to fully online, or else we will not be able to gain access to the schools, to the teachers, and to the students. It is very challenging because there is lack of human personal touch. There is also a lack of direct experiential learning. But what we try to adapt is, instead of bringing them, in big groups or big numbers, we could actually go as small little groups, and at appropriate times, and when the pandemic is not so bad. Yeah. So yes, it is a challenge for most of us environmental educators, because the direct experiential learning is a very important element, in influencing attitude, influencing behavior. But then we are still evolving with the pandemic to develop something that to come align or at par with the face-to-face method. Yes. Yeah.
Yeah, and there's a comment here from Dr. Hazel. Is there any possibility for you to extend such kind of very important research to other ASEAN countries, such as in the Philippines? This kind of research may carry the same impact as you have experienced in Malaysia. That's why actually under this program, we are basically collaborating with different academicians from different countries and also different universities. And Dr. Hazel, you are also invited. And all of our data, experiences, activities will be shared in our official website, which is www.meita.org.my. So all of us have an access to that website, which basically also link between all the academic institutions in the Asia Pacific and also in the European countries. So please do support us. All right. I think we have a good turnout and also a good discussion in this webinar. Before I end, can we have a group picture? Okay, please turn on your videos so we can have a group picture. Thank you for staying. Okay, Maya, can you take a picture of us, all of us?
Okay, can Doctor? Okay, ready?
Okay. There are different layers, I think.
Doctor, wait, Doctor. Okay, ready? Okay. 1, 2, 3. One more time.
Okay.
1, 2, 3. Okay.
Okay, thank you. All right, so before I end, I just would like to personally thank all the speakers for giving a very insightful discussion, very simple, in a simple and really understand. I also would like to thank all the attendees for the participation. I can see quite a number of MEITA collaborators from all around the world joining the session too. So please do support our MEITA program by checking out our website and join all our upcoming activities. We have a number of activities lining up, so stay tuned. And this project has just begun, so let's do it together. And I'll keep you updated on the next activities. Thank you. Happy Ramadan.
Selamat berbuka.
Selamat berbuka.
Bye.
Bye. Thank you.
Early there in Belgium, is it? It's just started.
Yeah, it is.
Okay, thank you everyone.
Right.
Okay.
Bye.
Thanks for
Bye. Terima kasih ya you all semua. Nanti kita ni buka puasa sama ke apa. Alright? Okay, bye-bye.
Bye, Doctor.
Bye.
Tengok ni. Tengok ni. Tak apa ni. Dia mendengar tapi dia kata dah habis.
Ada semua dah keluar langsung.
Ada 20 lagi attending ni. Satu lagi.